What up, cuz? It's Professor Tiwari here. After a confrontation, two criminals run away from a cop in different directions as shown. Criminal A runs 4.9 meters per second, while criminal B runs 3.6 meters per second. At what rate is the distance between the two changing when criminal A is 25 meters away from the cop and criminal B is 20 meters away from the cop? Now, in order to solve this, you need to set up a triangle with the hypotenuse A and the legs B and C. A equals 25 meters, B equals 20 meters, and to solve for C, you use a variation of the Pythagorean theorem. C equals 32.016 meters. You're also given dAdt and dBdt. Then, you differentiate the Pythagorean theorem, cancel out the 2's, and plug in your values to solve for dCdt. dCdt, or the instantaneous rate of change of the distance between the two criminals, is equal to 1.577 meters per second. Thank you, and God bless America. Hey guys, I'm back. Using the information as shown, how fast is the ladder falling? So, as you can see, this isn't a simple right triangle. The information that you're given is angle A is 1.641 radians, angle B is 0.773 radians. The length of A, or little a, is 10 feet. Length of little b is 7 feet. The angle B is decreasing at negative pi over 36 radians per second. Now to solve this and set up a relationship, use the law of sines. Then differentiate this law and plug in all your given values. After plugging in, solve for d little b dt. d little b dt should be, or the rate of change of the height of the ladder, equals negative 0.626 feet per second. Therefore, the ladder is falling at 0.626 feet per second. Peace.
So here we have a classic cone funnel problem, and we have to find the rate of change of the height of the rice as the rice pours into a cylindrical container from a cone-shaped funnel. The height of the rice in the funnel is decreasing at a rate of 0.12 inches per second, and the instant height of the rice in the cylinder is 2 inches. So what we have to do first is find the volume of the cone, which is 1/3 pi r squared times height. And so what we can do is set up a ratio between the radius and the height, and the radius is 3 inches and the height is 6 inches. Therefore, the height is equal to 2 times r. So we can find a new formula for that, which is 1/3 pi times h over 2 squared times h. Then we can further simplify that to be 1/12 pi h cubed. Then we can then take the derivative of that, which is 1/4 pi h squared times dh dt. We can plug in values to find dv dt, and so after plugging it in and simplifying it, we get dv dt to be negative 1.508 inches cubed per second. 508. And then find the volume of the cylinder in order to find the rate of change of the height of the rice being poured into the cylinder. Since the rice is being poured in from the cone into the cylinder, dV/dt is going to have the same value, except it's going to be positive. We can find the volume of a cylinder using pi r squared times height. The radius is 3 inches and the height is 2 inches, and since it's a cylinder, the radius won't be changing, therefore dr/dt is equal to 0. We can then differentiate the volume of the cylinder, which is 2 pi r dr/dt plus pi r squared times dh/dt. We can then plug in values to find dh/dt, which is 0.053 inches per second.
An explosion creates a shockwave that expands in a sphere. If the rate of volume that the explosion covers expands at 500,000 meters cubed per second, how fast should someone run when the radius of the shockwave is at 10 meters to avoid the shockwave? So first we need a formula that relates both the volume and the radius, which we can do by V equals 4/3 pi r cubed. Then we differentiate the formula so we have both dV/dt, which is how fast the volume of the sphere changes, and dr/dt, which is how fast the radius changes. And then we just plug in our known variables and we solve for dr/dt, which is 397.887 meters per second. So let's say that the energy produced by an explosion is given by the equation E equals 666 plus 9 times natural log of s, where s is the surface area. So first we differentiate this equation and we get 9 over s times ds dt. We don't know what ds dt is, so we have to go and find the surface area and the change in rate for it. So the surface area equals 4 pi r squared, so ds dt equals 8 pi r dr/dt. Then, now that we have ds dt, we can plug it in for ds dt and the dE dt formula. Then, after simplifying, we get 18 times dr/dt over r equals dE dt. So then we get the change in energy, which is 716.197 kilojoules per second.